So now that we understand the trends throughout history of these different greenhouse gases, how they break down by emission sources and sector, let's take a look at the consequences. So what consequences of climate change do we actually see? The American Geophysical Union, which is one of the nation's largest and most respected scientific organizations, has stated that, as best it can be determined, the world is now warmer than it has been in the last 2,000 years. Let me repeat that. The world now is the warmest that it has ever been within the past 2,000 years. That is since the beginning of civilization as we know it. If current trends continue, by the end of the century, it's going to be even hotter than any point in the last 2 million years. The average global temperature has climbed about 1 degrees Fahrenheit in the past century, and 19 of the 20 warmest years in the past 150 years have occurred since 1980. So this warming has resulted in some massive changes and devastation to our environment. So this just sums up what I said about the trends. We have global sea level that has risen approximately 8 inches in the past century alone. The persistent warming has done a number on permafrost. And so permafrost is melting. This puts in danger entire communities and ecosystems. In addition to that, also a whole bunch of infrastructure like houses, roads, pipelines, sewage systems, and transmission lines are being damaged as the ground sinks beneath them. And that is what is imaged here right behind this text, is melting permafrost. In addition, focusing on the northern latitudes, Arctic sea ice is only half as thick now as it was 30 years ago. And at the South Pole, the Antarctic ice shelves are breaking up. Nearly all mountain glaciers are retreating rapidly, and many have disappeared entirely. This is extremely made clear if you go to field sites that I study in Svalbard at 79 degrees north. We have a senior researcher on our team that has photographs of these same places that he surveyed 30 years ago. And the glaciers that we can barely find today were huge and massive when he started his expeditions up there. Satellite images and surface measurements show that growing seasons are now as much as 3 weeks longer in a band across northern Eurasia and North America than they were about 30 years ago. And droughts are becoming more frequent and more widespread. So in Africa, for example, droughts have increased about 30% since the year 1970. Marginal farmlands are becoming less productive as warmer temperatures evaporate any available moisture. Plants and animals are breeding earlier or extending their range into entirely new territory. So for example, in Europe and in North America, 57 butterfly species have disappeared from the southern end of their range, or they've decided to extend their northern limits. And that's because now in those northern limits, it's actually warmer. Many plants may be unable to migrate because they are rooted to the ground. And so these plants are especially susceptible to climate change and temperature increases because they're not able to migrate as rapidly as something that is mobile. Coral reefs worldwide are bleaching. That means they're losing their zooxanthellae, which are really crucial for their survival. These zooxanthellae, they can't live in water temperatures that are as high as 85 degrees in some places. And so they leave the coral or they just die altogether. So marine ecologists worry that warming oceans could be the final blow for our global coral reefs, which are already threatened by pollution and overfishing. And unfortunately, this would be a great loss for biodiversity and the ecosystems that are supported with the rich abundance of wildlife in these coral reefs. And finally, ocean currents are sluggish. This is especially dire when we go back and remember that the climate system on Earth is driven really by ocean currents and convection currents from the atmosphere interacting with the surface ocean. I just looked today about what is happening in this realm and how oceanographers are studying the trends of climate change on oceans. And actually, they've found and just published this that ocean currents are the weakest they have ever been within the past 1,600 years. This study was just published in Nature Geoscience called Current Atlantic Meridional or Returning Circulation Weakest in Last Millennium. So in this study, they measure that the Gulf Stream along the US East Coast is slowing down, and it's the weakest that it's been in this entire millennium. Now, unfortunately, that is the entire foundation for this apocalyptic movie called Day After Tomorrow. And that's when ocean currents worldwide stop, bringing about massive storms and devastation. It's an extremely scary movie. Predicted precipitation is expected to change both during the winter, depicted here on the left, and in the summer, depicted here on the right. So precipitation in the year 2100 is expected to produce wetter northern winters and drier southern winters compared to the recent averages. So here we have brown indicating really, really dry conditions and blue representing really wet conditions. So in winter, in the year 2100, the southern region of the United States and Mexico is predicted to become extremely dry, while the northern part of Canada is predicted to experience more precipitation. When we take a look at summers, we're expecting to have drier summers over most of North America, as you can tell by the bands of brown that are located from the very top of the United States through Florida. We will only see increases in precipitation in Alaska and other parts of Canada. So we discussed those species that are migrating, like the butterflies, for example, but we also need to remember that we are part of an ecosystem on this planet, and we too are a species that is reacting to climate change. So specifically focusing on our practices in agriculture and how the corn acreage harvested per county and soybean acreage harvested per county has progressively shifted northward. Taking a look at the year 1948 to 52, this was the expanse of corn acreage in the United States. Now compare that to the year 2008 to 2012. We've shifted our acreage northward. Same story for soybeans. Here was 1963 to 67. And now all of a sudden we have all of this acreage taking up soybean fields for 2008 to 2012. So controlling emissions of greenhouse gases is actually cheaper than the cost of climate change. In a 2010 study by the Pew Trust, they estimated that the cost of loss of ecological services by the year 2100 is going to be more expensive than the steps that it would take to mitigate those losses. The Pew Charitable Trust is an independent, nonprofit, non-governmental organization, or NGO, and they were founded in 1948. They have an endowment of about $5 billion, which it uses explicitly to fund research. So the costs that they estimated included factors such as lost agriculture productivity from drought, damage to infrastructure from flooding and from storms, lost biological productivity, health costs from heat stress, and lost water supplies. The Stern report estimates a cost of only about 1% of global GDP in the United States to avoid the worst impacts of climate change. So why are there disputes over the climate evidence? As I said before, the scientific consensus is crystal clear, and there is no internal dispute among climate scientists that climate is changing. So I'm going to go through some of the most commonly cited reasons that climate deniers cite for not wanting to support some of these green energy initiatives. So climate scientists offer the following responses to some of the claims in the popular media or by climate change deniers. Number one, reducing climate change requires abandoning our current way of life. It actually doesn't, because most of our infrastructure is deeply rooted in fossil fuel consumption, but it does require that we use different sources of energy and progressively transition from coal-based to more renewable-based. There is no alternative to current energy systems. There actually is. I mean, we can look to other model countries to set the example, including countries in Europe, China, and many island nations are showing that there are useful, reliable energy systems that are greener and better for the environment than fossil fuels. A comfortable lifestyle requires high CO2 output. Data actually shows that this is false. Simple as that. Natural changes such as solar variation can explain observed warming. So we did discuss in this lecture that there are natural cycles, including solar flares and those orbital cycles that will bring about climate change, but those changes are extremely slight, especially on the timescales that we are observing today, and those changes do not coincide with the speed and rate of climate change that we are currently observing. The climate has changed before, so this is nothing new. Today's carbon dioxide levels exceed anything the Earth has seen for nearly 1 million years. I'll say that again. The CO2 that we are living with right now at 415 parts per million is the largest that it has been within the past 1 million years. And the time it took to get from 280 to 415 is much more rapid than we've ever seen in any other period of Earth's history. So it's not only the concentration, but it's also the rate at which it got there. Temperature changes are leveling off. This is true on short time frames, sometimes. But over decades, the trend in surface air temperatures and sea levels continues to rise. We had cool temperatures and snowstorms last year, not heat and drought. So there might be regional differences in temperature and precipitation trends, and these are predicted by climate models, but by and large, when you take a look at the globe as a whole, the trend is to be warming. Climate scientists don't know everything, and they have made errors and misstatements. Believe it or not, fraud in data collection and in science is extremely rare. And the second it is found out, the scientists have to publish an erratum, they have to retract their paper, and they have to make public statements saying that they publish false claims. So fraud in data collection and science is almost unheard of. So what do we do to combat these increasing CO2 concentrations and the damage that this wreaks on our ecosystem? We have been envisioning solutions for many decades now. Former President Bill Clinton has argued that combating climate change doesn't have to mean economic hardship. In fact, it could be the biggest development stimulus since World War II, creating millions of green jobs and saving trillions of dollars in foreign fuel imports. So what are some of the strategies that we have available to us? There are many ways that we can control greenhouse emissions. We can actually, number one, directly reduce our dependence on coal, which produces more CO2 per energy unit than any other fuel. We could also institute fees for selling fossil fuels. These fees would help fossil fuel prices represent their many hidden costs. So instead of just paying for the fossil fuel, you're also paying for the cost to the environment. We can invest in new technologies and energy efficiency. And we can institute emission trading by instituting a legal cap on emissions and then allowing companies to buy and sell shares of that total cap on emissions. So there are international protocols that have been established to try to set some common rules across the globe. The United Nations Earth Summit that happened in 1992 was a meeting in Rio de Janeiro, and they set an objective of stabilizing greenhouse gas emissions. The Kyoto Protocol, which was signed in 1997, included 160 nations that all agreed to roll back their CO2 emissions, but also their methane and nitrous oxide emissions by about 5% below the 1990 levels by the year 2012. Unfortunately, China and India were exempted from the agreement, and the US never ratified the Kyoto Protocol. The most recent set of guidelines was established in the Paris Climate Accords. This is the most aggressive agreement yet that was set within the United Nations Framework Convention on Climate Change dealing with greenhouse gas emissions. And out of the 195 countries that were invited to this meeting, 174 signed the Paris Climate Accord. Now, this may be something you're familiar with or not, but in the year 2017, former President Trump withdrew the United States from the Paris Climate Accord. But on day one, our new president, President Biden, signed us back into the Paris Climate Accord. And that was the expiration date for when we would officially be out. So he did it on the very first day that he was able to. So in addition to countries setting standards for themselves, many of the largest business conglomerates in America have joined environmental groups to call for strong national legislation to achieve significant reductions of greenhouse gas emissions. Now, you would think tighter regulation and business interests really don't go hand in hand typically, and they normally don't. But those companies who are interested in setting up reductions on their greenhouse gas emissions would actually prefer a single national standard than a jumble of conflicting local state rules, because those cost them time, money, and sometimes contracts with potential trading partners. So they would actually prefer one centralized set of regulations. In addition to those approaches, what is called a wedge approach could help fix this problem. This is an alternative approach which breaks the problem that is huge into smaller bite-sized pieces that are more manageable and approachable. Each one might start small now, but their impacts through time will grow, producing a larger wedge-like impact, say in 50 or 100 years. So this was described by Pacala and Sokolow's paper that described 14, quote, wedges, each representing 1 gigaton or 1 billion tons of carbon emissions that could potentially be avoided by the year 2058. So what does this look like? Here we have the wedge analysis, or a wedge approach that incorporates multiple strategies to reduce or stabilize carbon emissions rapidly and relatively cheaply. So here we have the year 1950 all the way to 2050. We have billions of tons of carbon emitted per year. And looking in blue here with historical emissions, each one of these wedges represents a particular smaller scale strategy that could be implemented to either keep our CO2 emissions level or decrease them. So accomplishing just half of these wedges could level off our emissions, and accomplishing all of them could return to levels well below those that were envisioned in the Kyoto Protocol. So this includes things like driving less or driving vehicles that are more fuel efficient. We could incorporate sustainable building practices in our new infrastructure and architecture, and also properly insulate our new buildings. We can increase the efficiency of our power plants we can switch to more greener energy sources, and we can capture the carbon that we do emit. We could completely turn all of our existing energy sources into alternative energy sources. And then we could also protect forests and soils. So all of this combined takes us towards zero emissions. But if we were to incorporate none of them, this is our current path. And incorporating just some of them will keep us from gaining any CO2 per year beyond what we have. In addition to a federal centralized approach to addressing carbon emissions, there are also local initiatives everywhere. For example, Britain has already started to substitute natural gas for coal, promoting energy efficiency in homes and in industry, and also raising its already high tax on gasoline. The New Zealand Prime Minister has pledged that her country will be the first to be carbon neutral by the year 2050. Germany has reduced its CO2 emissions by at least 10% by switching from coal to gas and by encouraging energy efficiency throughout society. Denmark now gets 20% of its energy from windmills. And so in the United States, nearly 1,000 cities and 39 states have announced their own plans to combat global warming. And over 450 college campuses have pledged to reduce their own greenhouse emissions. Part of the motivation for these steps is that alternative solutions often are advantageous in their own right. For example, making buildings more energy efficient and buying high mileage vehicles actually saves money in the long run. And so adopting other strategies that can be taken up by individuals, like walking more, biking, climbing stairs, those are all good for your health, but they're also good for the environment because it'll reduce traffic congestion and energy consumption. And so as the Irish statesman and philosopher Edmund Burke said, nobody made a greater mistake than he who did nothing because he could only do a little. You might be thinking, okay, that sounds great. I would love some solar panels, sign me up, but I cannot afford that. And you're right, but just give it a little time because access to affordable and feasible technology is no longer the problem that it once was, even a decade or a few years ago. Renewable energy costs have plummeted as the market for them has grown, and many scenarios have been developed for converting to most or all energy production from renewable sources. There's a strategy that's been outlined by New York State to produce 100% of its energy with wind, water, and solar by the year 2030. So here we have some of the breakdown of what can be done in a state and envisioning how this could act as a model for the entire country. Taking advantage of wind resources, both on and offshore, geothermal energy, turbines, and solar panels. If environmental and our own personal health costs are included in accounting for fossil fuel costs, as well as the tax breaks and other subsidies for fossil fuels, these alternatives are substantially cheaper than conventional fuels. It's also a great idea to switch to these renewable sources of energy because it's been a leading strategy for reducing climate change and long-term stability, but also it allows a country to be energy independent. And that's a huge plus because global oil supplies are politically unstable and economically very volatile. Sweden is a leader in this, and they now produce 50% of their energy from renewable sources, including geothermal, biomass, wind, and actually biogas, which is methane that they take out from their garbage. Another thing to consider is this idea of carbon capture. Carbon capture would store the CO2 that's generated, but it's actually pretty expensive. So it's possible to store CO2 by injecting it deep into geological formations. And since 1996, Norway's state oil has been pumping more than 1 million metric tons of CO2 per year into an aquifer that is located 1,000 meters below the seafloor in the North Sea. The pressurized CO2 actually enhances oil recovery and saves on carbon taxes in Norway. Across the world, deep briny aquifers could store a century's worth of CO2 emissions at current fossil fuel consumption rates. So this entire process is called carbon management. And proponents of carbon management, as these various projects are called, argue that it might be cheaper to clean up fossil fuel effluents than to switch to renewable energy sources altogether. So by far, the easiest way to institute a cleanup of those fossil fuel effluents is to remove the CO2 from the coal-fired power plant and to a integrated gasification combined cycle technology. And this is described in chapter 12 if you're interested in reading about it. So to conclude, temperatures are now higher than they have been in thousands of years. And climate scientists say that if we don't reduce greenhouse emissions soon, we're going to be plagued with drought and flooding of cities. Exhaustive modeling and data analysis by climate scientists show that these changes can only be explained by human activity. And a stabilization wedge approach is a list of intermediate steps that could be taken to accomplish the needed reductions in greenhouse gases.